Assalamualaikum and hi everyone. In this video, we are going to learn about concentration. At the end of this lesson, you should be able to define molarity, density and percentage by mass. And then, you need to know how to perform calculations on molarity and percentage by mass, including dilution. Density is mass per unit volume. Therefore, to calculate density, we need to divide mass with volume. Common example of the unit of density is gram per milliliter. You can also represent the density with the unit of gram per liter, or gram per decimeter cube, or gram per centimeter cube. Let's have a look at example number 1. Calculate the density of a 50 ml solution with the mass of 10 gram. 50 ml is the volume of solution. While 10 gram is the mass of the solution. Therefore, to calculate the density, we can use this data to find out the value. So density is equals to mass divided with volume. Substitute the value, which is 10 gram for the mass and 50 milliliter for the volume, and then we will find out that the final value is 0.2 gram per milliliter. Let's proceed to the example number 2. The mass of 100 milliliter pure ethanol, so here is the volume of solution, is 78.53 gram, and here is the mass. At room temperature, calculate the density of pure ethanol in gram per milliliter. In this question, the unit of density is given specific, which is gram per milliliter. Therefore, the volume here needs to be converted into liter first. To convert milliliter to liter, we need to divide the value with 1000. Therefore, 100 milliliter divided with 1000 will result to 0.1 liter. Now, we can proceed to calculate the density by using the formula. Density is equals to mass per volume, where the mass is 78.53 gram, and the volume here is 0.1 liter. And we will get the final answer, which is 785.3 gram per liter. There are at least 5 measurements of concentration, but in this video, we are going to focus on molarity and percentage by mass. Molarity is defined as the number of mole of solute in a liter of solution. So make sure that to calculate molarity, number of mole of solute is divided with the volume of solution in liter. Common example of the unit is mole per liter, where 1 mole per liter is equals to 1 mole per decimeter cube, as well as 1 molar. This capital M is pronounced as molar. it is the unit of molarity. Solute is the substance present in smaller amount in the solution, while solvent is the substance present in larger amount in the solution, while solution is a homogeneous mixture of two or more substances. In this example, if we want to prepare a hot chocolate beverage, we need to have cocoa powder as the solute, hot water as the solvent. When we add hot cocoa to the hot water, we will produce a hot beverage, which is a hot chocolate. Number of mole of solute can be calculated from the mass of solute, while the volume of solution is either given in the question or can be calculated from the density of the solution. Make sure that the volume of solution is in liter. Let's try example number 3. Calculate the molarity of a 50 ml sodium hydroxide solution. So here is the volume of solution. Prepared by dissolving 10 gram of anhydrous sodium hydroxide. So here is our solute, the mass of solute. In distilled water. We know that to calculate molarity, we need to have mole of solute and volume of solution in liter. Therefore, we need to calculate the number of mole of solute from the mass of solute and make sure that the volume of solution given here is in milliliter, so we need to convert it to liter. So, mole of solute in this case it is anhydrous sodium hydroxide, so mass is divided with molar mass. The mass is 10 gram, while the molar mass of sodium hydroxide can be calculated from the relative atomic mass given in the question. So, sodium plus oxygen plus hydrogen. Therefore, the value is 0.25 mole. Then, we need to calculate the volume of solution. We need to convert the value from milliliter to liter by dividing it with 1000. So, volume of solution which is 50 milliliter is divided with 1000 so that we get 0.05 liter. Now we have both mole of solute and volume of solution in liter. We just need to substitute the values into the formula. Mole of solute 0.25 mole divided with volume of solution in liter, which is 0.05 liter. We proceed to calculate the molarity, which is 5 mole per liter. You can also present the value as 5 molar. Both are correct. Let's proceed to the next measurement of concentration, which is percentage by mass. Percentage by mass is defined as percentage of the mass of solute per mass of solution. Therefore, the percentage by mass can be calculated by dividing mass of solute with mass of solution and then times with 100. Remember that mass of solution is equals to the mass of solute and the mass of solvent. I have 3 candies here with a mass of 15 grams and the mass of solvent here, which is usually water, which is 85 grams. When I mix the solute with the solvent, a solution will be produced with a mass of 100 gram. The mass of solute, which is 15 gram, plus the mass of solvent, which is 85 grams, will result to the mass of solution, which is 100 gram. Therefore, the percentage by mass of candies in the solution is 15 grams divided with 100 grams, which is the mass of solution, times with 100. And it will result to 15% of candies in the solution. Let's try the example number 4. Calculate the percentage by mass of 5 gram of sodium chloride dissolved in 25 gram of distilled water. So here is the mass of sodium chloride, which is our solute, and 25 gram of distilled water, which is the solvent. We know that to calculate the percentage by mass, we need to have the mass of solute divided with the mass of solution times with 100. Therefore, we need to find out the mass of solution first. As we know previously that the mass of solution is equals to the mass of solute plus the mass of solvent. Therefore, the mass of solute, which is 5 grams, times with the mass of solvent, which is 25 grams, will result to the mass of solution, which is 30 grams. Now we have the mass of solute, which is 5 grams, and the mass of solution, which is 30 grams. Now we can substitute all the values. 5 grams for the mass of solute divided with the mass of solution, which is 100 grams, 30 grams, times with 100. This will result to the final answer, which is 16.7%. Dilution. Dilution results in reduced concentration of the solution. However, the number of moles of solute in the solution remains. Therefore, we can conclude that the number of mole before dilution is equals to the number of mole after the dilution. As you can see from the picture here, initially there are 3 moles of particles A in this amount of volume. When solvent is added, the total volume increased, but the number of mole of solute of particles A still remains the same, which is 3. Therefore, the 3 moles of the particles occupied a greater number of volume. This will reduce the concentration, but the number of moles remains the same. Because we know that concentration is equals to number of mole divided with volume of solution. When the solvent is added, the new volume of the solution is now higher than the initial volume. Therefore, the concentration is reduced, but the number of moles of solute remains. Molarity is equal to number of mole of solute divided with volume of solution. Rearranging the above formula results to number of mole of solute N is equals to molarity M times with the volume of solution V, or N is equals to MV. Since dilution reduced the molarity but the number of mole remains, number of mole of solute before dilution N1 is equals to the number of mole of solute after the dilution NF. We can conclude that molarity initials time with the volume initial is equals to the molarity final times with the volume final. This is the formula that you are going to use when calculating the new concentration of the diluted solution. Let's have a look at example number 5. A 25 ml of 0.5 molar HCl solution is diluted with 75 ml of distilled water. Calculate the concentration of the resulting solution. As you can see here, the initial concentration is 0.5 and the volume initially is 25 ml. When 75 distilled water is added to the solution, the total volume of the final solution will change. Therefore, the new volume for the new solution is 25 plus 75 milliliter. This will result to 100 milliliter. The question asks you to calculate the concentration of the resulting solution. Therefore, we want to find out what is the value for the final molarity. We know that to calculate the new molarity of the new solution, we can use the formula of M1V1 equals to MFVF. By substituting all the values given in the question, 0.5 molar for the initial concentration and 25 milliliter for initial volume, we can calculate the final molarity of the new solution. The final volume of the new solution is 10 milliliter. And then you can calculate the final answer will be 0.125 molar. Quote of the day: concentration and mental toughness are the margin of victory. Bill Russell. Before we end the lesson today, let's try some exercises. Exercise number 1. A solution with the density of 1.1 gram per milliliter contains glycerol, C3H8O3 and water. If the solution consists of 66 gram glycerol and 46 gram of water, calculate the percentage by mass of glycerol. So from the question, we are given with the mass of glycerol, which is 66 gram, which is the mass of solute, and 46 gram of water, which is the solvent. So this is the mass of solvent. We know that to calculate the percentage by mass, we need to have the mass of glycerol, which is a solute, and the mass of solution. Therefore, mass of solution is equals to mass of solute plus with the mass of solvent. (66 gram) plus with 46 gram, and the answer is 112 grams. So now we can calculate the percentage by mass. Percentage by mass is equals to mass of solute divided with mass of solution times with 100. Substitute the values and you will get the answer. Still on the exercise number 1, but this time the question asks you to calculate the molarity of the solution. We know that molarity is equals to mole of solute divided with volume of solution. Therefore, we can calculate the mole of solute from the mass of solute here, which is 66 gram of glycerol, and volumes of solution from the density. Let's try this question. Mole of solute is equals to mass divided with molar mass. The mass given is 66 gram of glycerol divided with the molar mass of glycerol, which is based on the molecular formula here. So 3 times 12 plus 8 times 1 plus 3 times 16 gram per mole. When you calculate the value, you will find that the value is 0.7174 mole. Next, we want to calculate the volume of solution. We know that previously density of solution is equals to mass of solution divided with the volume of solution. So density is equals to mass of solution divided with the volume of solution. The density of the solution is 1.1 gram. Per milliliter. For the mass of solution, we need to calculate it first. Mass of solution is equals to mass of solute plus mass of solvent. The mass of solute is 66 gram and the mass of solvent is 46 grams. Therefore, the answer is 112 grams. We can substitute this value into here, mass of solution. So 112 grams here. Now we can calculate the volume of solution, which is 101.8 milliliter. The unit is milliliter because the unit of density here is gram per milliliter. To calculate molarity, we need to make sure that the volume used is in liter. Therefore, divide the value with 1000 and we will find that the volume of solution is 0.1018 liter. Now we have the values for both mole of solute and volume of solution. Substitute the values into the formula. Mole of solute is, which is here, 0.7174 mole divided with volume of solution in liter, which is 0.1018 liter. And you will find the final answer, which is 7.047 molar or mole per liter. Now let's try exercise number 2. A sulfuric acid H2SO4 solution of 95% by mass has the density of 1.84 gram per milliliter. Calculate the molarity of the solution. First of all, we know that to calculate molarity, we need to have the number of mole of solute and the volume of solution in liter. To calculate this, we need to do some assumption from the percentage by mass given in the question. 95% by mass. The assumption goes like this. We need to assume that the mass of the solution is 100. Therefore, the mass of sulfuric acid or the mass of H2SO4 is 95 grams. Remember that H2SO4 is the solute here, while the mass of solvent which is usually H2O or water is 5 grams. This will result to the total of mass of solute plus mass of solvent 100 gram as the mass of solution. This is the assumption that we need to do in order to answer this question, because no mass is given in the question. Now we have the mass of sulfuric acid, so we can calculate the mole of solute from this mass. Mole of solute which is our H2SO4 is equals to the mass divided with molar mass. The mass is 95 grams divided with the molar mass of sulfuric acid, which is 2 times 1 plus 22.1 for the sulfur plus 4 times 16 for the oxygen. Therefore, we will find out that the mole of solute is 0.9684 mole. Now, by using the density of solution, we can calculate the volume of solution. Density of solution equals to mass of solution divided with volume of solution. Substitute the values. From the question, we know that the density of solution is 1.84 gram per milliliter equals to mass of solution. We can get it from here, from the assumption. So 100 gram divided with the volume of solution. So volume of solution is equals to 54.35 milliliter. The unit is milliliter because the unit from the density is gram per milliliter. Therefore, the volume of solution obtained from this calculation is in milliliter. However, to calculate the molarity, we need to convert the volume of solution to liter. So we need to divide the value with 1000. And we will get 0.05435 liter. Now we have the values for both mole of solute and volume of solution in liter. We can substitute the values into the formula. Mole of solute is 0.9684 mole divided with the volume of solution, which is 0.05435 liter. And this will result to final answer, which is 17.82 mole per liter, or 17.82 molar. Both units are accepted here. We are still in the exercise number 2, but for the next question, the question asks you to calculate the volume of the acid needed to prepare 1 liter of 0.08 molar H2SO4 solution. These are the new solution or the final solution. So the question asks you to find out how much of the volume of the initial solution or the stock acid needed to produce the new solution. Okay, so as you can see here, the initial concentration as obtained from the previous question is 17.82 molar. How many of this solution is needed to produce the new solution with 0.08 molar and with a volume of 1 liter? Now we can use the formula, which is M1 V1 for the initial solution equals to the MF VF, which is from the final solution. Just substitute the values. Initial concentration is 17.82 molar times with the initial volume needed, equals to the new concentration of the new solution, which is 0.08 molar, times with the volume final, which is 1 liter. You can use your calculator and find out that the final answer will be 4.489 times 10 to the power of negative 3 liter of the initial solution needed. As you can see here, the volume is in liter because the value of the final volume substituted in the formula is in liter. Finally, let's try exercise number 3. A saline solution is prepared by dissolving 9.0 gram of sodium chloride in deionized water in a 50 ml volumetric flask. Calculate the molarity of the solution. This is a simple question since the mass of the solute is given. And the volume of the resulting solution is also given. As we know that molarity is equals to mass of solute, number of mole of solute divided with volume of solution. In liter. First of all, we can calculate the mole of solute from the mass of solute. Mass divided with molar mass. The mass is 9 grams. The molar mass of sodium chloride is 23 for sodium and chlorine 35.5 gram per mole. And you will find that the value for the mole of sodium chloride is 0.1539 mole. Don't forget that to calculate the molarity, the volume of solution needs to be in liter. Therefore, we need to divide 50 ml with 1000 so that we will obtain the volume in liter, which is 0.05 liter. Now we have both the values for the mole of solute and the volume of solution. We can just substitute the values into the formula. Mole of solute 0.1539 mole divided with the volume of solution, which is 0.05 liter. And you can use your calculator to find out the molarity. The value is 3.078 mole per liter, or 3.078 molar. Both units are excellent. Let's have a look at exercise 3, part 2. In this part, the question asks you to calculate the volume of water added to dilute 25 ml of the solution to 1 molar. So this is a new concentration that we want to achieve by taking only 25 ml of the initial solution with the concentration of 3.078 molar obtained previously from the question here. We know that the final volume of the final solution is 25 ml, which is the initial volume, plus with the volume of water added. To calculate the VF, or the final volume, we can use the dilution formula, which is M initial equals M initial times V initial equals to M final times V final. Substitute the values. The total volume of the final solution is 76.95 milliliter. This is the total volume, but the question asks you to calculate the volume of water added, and we know that the volume of water added is equals to final volume minus 25. So we can substitute the values obtained from here. 76.95 milliliter equals to 25 plus the volume of water added. Therefore, the volume of water added is equals to 76.95 minus with 25 the initial volume. This resulted to 51.95 milliliter. I hope you have watched all the slides in these videos and try all the questions given. Thank you.